Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray, and in this video we'll be looking at how to write the trigonometric ratio of any angle into the form of an acute angle using allied angles. So let's get started. So we can convert any trigonometric ratio of a very large or a very small angle into the terms of an acute angle using the formulas of allied angles. Okay, so what are allied angles? Say theta is an angle, then angles of the form minus theta or pi by 2 plus minus theta, pi plus minus theta, 3 pi by 2 plus minus theta, and etc. You get the idea, are known as allied angles of theta. So what allied angles basically are? Multiples of pi by 2 plus minus theta. The angles of this form are known as allied angles of theta. Now, any big angle can be written in the form of an allied angle and then converted into the trigonometric ratio of an acute angle. So what are the rules that the allied angle formulas follow? First I write down the rules, and then we will see how do we get this rule by finding the allied angles formula for some angles and then getting to the conclusion. Okay, so the two rules that are used to write the allied angles formula are: first one, the trigonometric ratio changes when allied angles are of the form 2n plus 1 into pi by 2 plus minus theta. When the allied angles are of the form odd multiples of pi by 2 plus minus theta, in that case the trigonometric ratio changes from sine to cos, cos to sine, tan to cot, cosec to sec, sec to cosec, and cot to tan. Okay, so if what these angles are basically, if angles are in the form 2n plus 1 pi by 2 plus minus theta, 2n plus 1 into pi by 2 are angles which lie on the y-axis. That means angles such as pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, so on. Also minus pi by 2, minus 3 pi by 2, minus 5 pi by 2, minus 7 pi by 2, and so on. If it is in the form of this, then we change the trigonometric ratio from sine to cos, cos to sine, tan to cot, cosec to sec, sec to cosec, and cot to tan. Also, the trigonometric ratios remain the same if allied angles are of the form 2m plus minus theta. So ratios remain the same if angles are of the form m pi plus minus theta. That means if angles are of the form an angle on the x-axis that means either it is 0 or pi or 2 pi or 3 pi, 4 pi, and so on, or minus pi, minus 2 pi, minus 3 pi, and so on, plus minus theta, if it is in the form of this, then the trigonometric ratio remains the same. Now the second rule of the formulas of allied angle is the sign, whether it is positive or negative, of the resultant trigonometric ratio depends on the sign of the original trigonometric ratio in the quadrant in which the original angle lies. This is the second rule for the allied angles. Now if we apply both of these two rules, we will be able to make any trigonometric ratio of any angle in the terms of an acute angle. So let's see how that goes. Alright, so let's look at these three examples. So first we have sine of 37 pi by 6. Now 37 pi by 6, we have to make this into the form of an allied angle first. So this can be written as, see, this can be written as sine of 6 pi plus pi by 6. Correct? Because if I take the LCM, this will be 36 pi plus pi upon 6, which is 37 pi by 6. So sine 6 pi plus pi by 6 is now in the form of an allied angle. So sine 6 pi plus pi by 6. Now apply the two rules that we have learned. Okay? So the first rule was the trigonometric ratio remains the same if the angle is of the form m pi plus minus theta, and this is of that form. That means this is m here is 6, this is m pi plus minus plus pi by 6. So this angle is a multiple of pi plus pi by 6, right? So the trigonometric ratio remains the same. So we'll write sine of pi by 6. Now the sign of this trigonometric ratio, whether it is positive or negative, it depends on the original trigonometric ratio and the angle in which quadrant this angle lies. So 6 pi plus pi by 6, let's look at it. This is pi, then 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. 6 pi will be here on the positive x-axis. Plus pi by 6 means that we are in the first quadrant. So in the first quadrant, sine is positive. That means the resultant trigonometric ratio will also be positive. So we will write it as sine pi by 6. Now let's look at the second example, cos of 2220 degrees. First we will change this angle to a form of an allied angle. So it can be written as cos of 2160 degrees plus 60 degree. This is a multiple of pi. Or it can also be written as cos of 2150 degrees minus 30 degrees, 2250 degrees minus 30 degrees, where this angle is an odd multiple of pi by 2. Correct? Now, cos of a multiple of pi plus theta means, if we apply the first rule here, that the trigonometric ratio will remain the same if the allied angle is of the form m pi plus minus theta. So here the angle will remain the same, the ratio will remain the same. So this will be cos 60 degree, right? Now the sign of this will depend on the trigonometric ratio, original one, and the angle in which, and the quadrant in which this angle lies. So this angle will mean, where will it lie? Let's look at it on the coordinate plane. So 360 is complete here. Again 360, 720. 720 plus 360 will be here. That is 1080. And 1080, double of that will be 2160. So we will go round again 3 times to reach 2160 degrees here on the positive x-axis. Plus 60 degree means we are in the first quadrant. So first quadrant, cos is positive, so we will put a positive sign here. Let's look at this, the second option. Now this can be written as This is also valid, it is in the form of an allied angle. So now cos of a multiple of pi by 2, this 2250 degrees will be here on the positive y axis. This will be 2250 degrees minus 30 degree. So now it is an odd multiple of pi by 2 plus minus an angle. That means that the trigonometric ratio will change according to the first rule. So cos will be written as sine, and this will be sine 30 degrees. Now the sign of this resultant will depend on the sign of this ratio in this for this angle. So again it is in the first quadrant, so cos is positive, so we will get positive sine 30 degree. Sine 30 degree and cos 60 degree are the same, both are equal to 1 upon 2. That's why both answers are 100% correct, right? Alright, let's look at the third example, tan 11 pi by 3. Now first we'll write it in the form of an allied angle. So tan 11 pi by 3 can be written as 4 pi minus pi by 3, right? So this is equal to, now 4 pi is a multiple of pi minus this angle, that means the trigonometric ratio will remain the same. This will give me tan pi by 3. Now the sign will depend on the original ratio in the quadrant in which this angle lies. So this angle 4 pi, that means we are going around 2 times 4 pi to reach the positive x axis, and then minus pi by 3, that means we are here in the fourth quadrant. In the fourth quadrant tan is negative, so we will put a negative sign here, and this will be our answer, minus tan pi by 3. Okay, so I hope you understood the allied angles in this video. If you did, hit the like button and subscribe to our channel, and we'll be posting more videos like these. Thank you.